we're going to hit the start button. It's going to start filling. Okay, so the system is filling. Very, very, very simple logic. And again, it could be done many different ways. I'm just showing you how to make the system work together. How I got the scope of work. How I tied the OPC together. How I made everything work with Machine Simulator. So again, we built this machine on the last video. And again, if you haven't seen that, go back and watch that video. But again, when it comes down to it, we want to make sure we understand how everything works together in a real world OPC topic, right? So many different things. Many times do we use OPC topics with third-party entities, right? So it's best you use this and know how it really works and how everything ties together, from RSlinx to the third party to how everything works, and then get everything functional. So, all right, in our last video, we built a actual machine in Machine Simulator in Easy PLC, right? So this one, we're going to actually program that machine. We're going to get our scope of work. We're going to program a simple little program using Studio 5000, and we're going to emulate that processor. I'm going to build that right now. I'm going to name this program Tank Sim, and then we'll just go ahead and clear that. So we'll make this, and we'll make this version, again, Studio 5000. We're going to make it version 31. Let's use slot 8. Now we will be using a emulator. I have an emulator in slot 8 right here. Matter of fact, I'll throw that in program right now so we don't have any problems later. Simply just add or create one. That's as simple as that is. So there is no real world processor involved in this. However, you can use a real world processor. Okay, so we're going to keep that open. Make sure we're communicating all our processes out to what we're using. All right, so you might be questioning yourself, what do you mean in the last video we made a machine? In the last video, we made this machine. It says My Mixing Tank. Okay, so I'm going to start that one. Okay, so let's start it. What we're going to do, we're going to get a scope of work. Okay, so first off, our program's being made, right? So let's go ahead and get these side by side. So you can see this is a brand new program. It has nothing inside of it. Let's go ahead and while we're here, and let's go ahead and change the task from a continuous task to a periodic task. A lot of people ask me why I do periodic tasks. It's because of timing, and I'm just going to choose the timing of 47 milliseconds. And a lot of people ask me, why do I use 47 milliseconds? Really because I did a lot of motion and stuff in the past, and with synchronous motion at 47 milliseconds just seemed to work out just perfect. But again, that's based upon the machine, so that's just a number that sticks in my head for some reason. Okay, so there's no preference to that besides other than you can put it whatever milliseconds you want. So that is a periodic task now at 47 milliseconds, and we can actually name that right here _ 47 milliseconds, so we understand that it is a periodic task of 47 milliseconds. You can see it on the outside. There's no tags in here yet. How are we going to get our tags? It's a very good question. I'm going to open this up real quick. Now, this is the tank we made. Okay, so remember in the last video we made this tank. We made this machine. Okay, we added the start push button. All right, so I'm going to go to View IO. Now I'm going to open up a notepad. Okay, so I have a notepad right here that I'm going to open up. We're going to get our scope of work with our notepad. And you might be wondering, how are we going to get our scope of work? Okay, so that's why we did the View IO right here. So we did the View IO so we can see the start. This starts the light. Okay, so we can see the input valve. That does the input valve. This does the output valve. Also, too, the input light. You can see this is the input. We have an analog input, so if you come over here, you can see the analog value coming in. So there's only a couple things we actually care about in this actual program, or to make this program work. We're going to make a real simple program, okay? And what we're going to do is we're just going to fill up the tank. We're going to hit the start button, fill up the tank, let it fill up to a certain amount, and then we're going to allow it to discharge. All right, so first we need our outputs, okay? All right, which our outputs are going to be the start light, okay? And the next one's going to be tank fill valve. Okay, and you can separate these, if you wanted to, but they're going to separate naturally. You can't have any in Studio 5000 or Logix 5000. You can't have any, like spaces or anything like that. So when it comes down to it, just make sure you use an underscore or something like that if you want to separate the wording. And this will be tank discharge. And we'll put valve, just so you understand. Okay, so that gives our outputs. We need our inputs. Our inputs are what? So our inputs are going to be right here. Digital input, that's our start button. That's right here. If we push the start button, you see it comes on. So that's how we got that scope of work. All right, so start PB, real simple. Now we need our analog input, right? So our analog input is our tank fill level. So we're going to get our analog, and all I'm doing right now is getting the scope, right? So analog input will be tank level. Okay, real simple. So we have our outputs, our inputs, and our tank level, our analog. All right, so with that said, we have everything we need to build our program, our Studio 5000 program. So let's go ahead and build that real quick and get that full screen. And we're going to come in here, we're going to do our first rung. I like to go ahead and throw in all of my digital bits, whether they're inputs or outputs. I throw all of my digital bits right here. And if you can count, what we have is 4 digital inputs, or digital inputs and outputs. And then we have one that's going to be a analog. So let's go ahead and do a move for our analog. And let's go ahead and build that one first. So we'll do that. And what we have right here, we'll just copy and paste this because we already added it, so why duplicate work? We're going to change this data type to a real, so we get a decimal point. Okay, so we have this in here, we have our tank level in there now. So now what we need to do is get our inputs and outputs, right? All right, so our inputs, our first outputs, let's say this is the start light. We're going to make a new tag, paste that in there, start light, real simple. I kind of like that to be separated word. It's just easier to read. That's just my preference. So it's all about preference. When you make these tag names, it's all about preference, so just keep that in mind. With Studio 5000 and with Logix 5000, well, you have the ability to name the tag whatever you want to, so why not make it user friendly? Why not make it easier for the person behind you to read it? That's just the way I think about it, right? So we're adding all of our bits, so we're essentially making our tags right now. That's all we're doing. All right, so now let's do a programming. We're going to add a couple rungs in here, and as I use these things, I'm going to actually get rid of the stuff up top. What do I mean by that? Is if I drag the start button down here, I'm going to get rid of it. Then I'm going to come down here and I'm going to say, okay, well, I want to seal in this start button. I'm going to use a seal in circuit and say, okay, let's use the tank fill valve, and let's also come over here and do bits, and let's cut on certain bits. Let's do 2 bits that we're going to cut on. We're going to do the tank fill. We're going to copy this, the tank fill, and then we're also going to do our start light. So the next one we'll grab is our start light right here. Okay, and then we need something to break this seal-in circuit. So let's come over here and say compare, and let's say less than, and let's use our tank level, and let's say the tank level is less than 1,000 pounds. Okay, or 1,000 gallons, whatever the case may be. I think it's pounds that it equates to. So when it comes down to it, that's what we're going to do. All right, so now let's say we want to do our discharge. Now we used our start light too, so let's get rid of that. So we know all the stuff that we have. All we have to do really right now as our scope is we need to do our discharge valve. Okay, so what we're going to do is we're going to come over here and let's get a greater than or equal to. So greater than or equal to, and then we'll use our tank level again, and we'll say 1,000. And greater than or equal to obviously is going to say, hey, either or, right? That's why we're using that. We're going to seal that in. We're going to get our tank discharge, so we're going to immediately discharge our tank as soon as it hits the level that we want it to. We're going to seal that in, right? We're going to allow that to seal in as long as, so right here, we're going to seal that in as long as the tank level is above 1000. So if the tank level is above 1000, so we'll say tank level, and we'll actually come back in and compare. We'll say as long as it's greater than 0. So if the tank level is greater than 0, we will allow this to happen. Okay, if it is actually not greater than 0, then it will unlatch. Okay, so that's basically how we got that. We got that just done. So let's delete our rung up here. It's a very, very, very simple logic. Again, you can do logic as much as like many different ways. Let's actually blow this up so you can see it a little bit better. So you can see there's a start button, fill, it's going to latch itself in until it gets to above 1,000 pounds. And then when it gets above 1,000 pounds, what it's going to do is going to unlatch itself. It's going to actually turn on the discharge. When it turns on the discharge, what it's going to do at that point is it's going to come over here and allow the tank to discharge until it gets, well, you know, below or equal to 0. Now we still need to make our OPC. So what we need to do first is we need to download to our processor. So I'm going to go over here to communications, and we're going to go to our ABVBP1, which is our virtual backplane. We're going to see that we have our tank right here, our processor right here in slot 8. Right? We're going to go ahead and download to that processor. Now if you have trouble downloading to that processor, again, that's why you've seen me make sure it's in program mode. Again, that's generally the problem with emulator. If you're using emulator, if you're not using emulator, if you're using like a processor, a real world processor, make sure it's in program mode. And again, just download to that processor. So with that said, we're downloading. Okay, so let's make sure everything goes accordingly and we don't have any errors in our program, which again, I don't see why we would. It's very, very, very simple logic. So with that said, real quick download time. Let's go ahead and throw it and run. It's not going to do anything because, well, it's not tied to anything yet. Alright, so we have it programmed. We still have to make our OPC. So let's go on to RSlinx. Let's go to DDE OPC, and let's go to, and you have to have in the OEM version. You cannot do this with a light version. So RSlinx Lite will not do this. So to use OPC topics, you have to have this into you know, a higher level, well, a licensed version, if I want to say that correctly. All right, so make a new topic, and our new topic is going to be, let's just call this my tank, and let's point that topic to the processor that we downloaded to, which is the, again, this is a Studio 5000 Logix emulate processor. Let's hit apply. Now we've done our OPC topic. Okay, now we need to come into our program, our machine simulator right here. We're going to go to IO drivers. First, let's run this out. Let's actually restart this machine. Instead of running it out, let's restart it. Come over here to IO drivers. We're going to pick our driver that we're going to use. And in this driver, we're going to actually get the OPC underscore driver underscore enhance, right here. Then we're going to actually, well, we're going to assign our drivers because we have our inputs and our outputs, and we have our analogs down here. So let's go ahead and assign our inputs. Okay, so currently you're not going to have anything in here, so it's unfair. So I'm going to go ahead and do the exact same thing that you're going to see. Yours is going to be blank, completely blank like that. So this topic name right here needs to match your topic of your OPC that you're running. We called our topic my tank. Okay, so in that statement, I need to have that say my tank. Okay, and then we need to add in our inputs and outputs. Okay, so our outputs are our inputs, right? So if we have, what I mean by that is like right here, if I was to add, let's add our start push button, which is right here. We're going to grab that push button, we're going to come over here, and we're going to add that in right here. So that's going to get our start push button. Our outputs, we're going to add that in, let's see, the first output we have. I want to do this in sequential order. So what I mean by that, is if I were to go right here, I see my start light first, I see my tank fill, I see my tank discharge, and in that order. Okay, so I want to go ahead and put those in there in that synchronous order. So I want to do my start light first. Okay. Alright, so my start light first. Put that in there. And then I want to come in here to my next one is going to be, if I go over here, it's going to be my fill. So I'm going to do my fill. And I'm doing this in this synchronous order so that I don't have to drag and drop. And I'll show you that in just a second. Okay, so we'll go over here. We've got one more we need to add, which is our tank discharge valve. Okay, tank discharge valve right here. Put that in there, accept it. Now we need our analog value, which is our tank level, right? So our tank level, grab that, grabbing this. And all of this is just making our OPC work together. So our tank input, right? Put that in there, and that would be everything we need, I believe. Let me make sure I have this in there in the correct way. This is an output, this is an output, this is an output. So I believe I need this one. I need to have this in here to get the right. So let's see. Okay, so come over here. Now we have our OPC right here. So we have our inputs over here, which is our start button, and we have our tank level. So we can drag this over here just like this if we wanted to, but I put them in synchronous order, so all I should have to do is go to auto assign, just like I just did right there, and then everything should auto assign to the proper thing. Again, when it comes down to it, then I go to start driver. Okay, now as soon as I have my driver's actually started, it has a driver connected. I can also go to my OPC or my RSlinx Classic, go to my OPC topic and make sure it's already like it has a lock symbol on it right here. Alright, so with that said, we should be able to actually start the system. So let's see if we did everything correctly. We're going to let this thing run, and you can see that we're going to run this thing up to 1,000 and 1,000 gallons, 1,000 pounds. I think it's tank level, so with the tank level is 1,000, and then it should unlatch itself. Okay, it should actually unlatch itself and then start the discharge. Now we'll see this process work again, and you see the start lights on, you see the process working. I'm gonna actually get these screens side by side so you can see the logic working along with this, but it's very, very simple. So you see that's actually working. So let's shrink this down. Let's shrink the logic down so you can see all of this working side by side. And let's see if I can resize my screen so that you can see this stuff. I'm gonna shrink the I/O so that's not in the way of seeing everything. Okay, so let's do this one more time while you can see this side by side. Okay, so now the logic is here. Alright, really simple. You see that the valve discharge unlatched itself, so we're back in a normal state. We're going to hit the start button. It's going to start filling. Okay, so the system is filling. Very, very, very simple logic. And again, it could be done many different ways. I'm just showing you how to make the system work together. How I got the scope of work. How I tied the OPC together. How I made everything work with Machine Simulator. So again, we built this machine on the last video. And again, if you haven't seen that, go back and watch that video. But again, when it comes down to it, we want to make sure we understand how everything works together in a real world OPC topic, right? So many different things. Many times do we use OPC topics with third-party entities, right? So it's best you use this and know how it really works and how all everything ties together, from RSlinx to the third party to how everything works, and then get everything functional. So side by side you see the things working, right? So with all that said, we just want to make sure that you get a good clear perspective. And since we're here, what we need to do is let's go ahead and save our program. We'll save as, and then we'll just call this my projects, and just save it just like that. So we have it for later. Also too, We can save our driver for our tank right here. What we can do is we can stop the whole machine and then save our driver, save how everything is set up, so that when later we go to start that, we have a driver we can load from Machine Simulator. Now again, so this is just a real simple, really simple program, really simple logic, really simple way to do things. There's not a stop button. I'm just having it fill all the way up, do a batch, and then empty out immediately. Real simple, no complexity to it whatsoever. So the key points behind this was really to tie in your OPC server with your OPC topic with your Machine Simulator, get it all working, and then again with it all working on a simulator environment. And again, you don't have to use an emulator. I'm using an emulator. You can use a real world processor if you want to. So let's get this full screen again. Let's reset the machine. Come over here. We'll come over here and we can actually auto assign our driver, and then we can save our driver as far as that goes. So again, when it comes down to it, I just want to show you how all this stuff works. So we'll save and exit, and again start the system. That's just how it works. So with all that said, I wanted to show you how all that worked, and hopefully that you gained a lot out of this. I know for some of you guys that are more advanced programming, you know this is kind of remedial, but again, when it comes down to it, hey, some people need to see the whole process working, see how easy it is. Again, we did build this machine from scratch, so this is our machine. We built it using Easy PLC's Machine Simulator. Hopefully you watch that video, you watch this video, you see everything tying together, how easy it was, how simple it was. It was done within, you know, a 40-minute time period. And well, with that said, we'll see you guys on the next one.